Hello viewers, this is Dr. D. Rajalakshmi, Associate Professor in CSE Department of RMD Engineering College. In today's session, we are going to see Travelling Salesman Problem using Dynamic Programming Technique. Travelling Salesman Problem is a problem of finding shortest tour that visit every city exactly once and return to the city from where it started. Let's take an example to understand the travelling salesman problem in more detail. This is the problem given to us. Here the nodes and the vertices. Nodes or vertices represent cities and the values in each edge denote the distance between one city to another. Here we are going to use dynamic programming technique for solving this travelling salesman problem. According to dynamic programming technique, this is the formula we are going to use to solve the problem. G of I, S is equal to minimum of Cik plus G of K, S minus K. This is what is the formula. Where this G of I, S represents the minimum distance to reach the starting city from the city I through the intermediate cities S. Assume that we are starting the tour from vertex number 1. After visiting vertex number 1, we have 3 possibilities to visit second city. Vertex number 2 we can visit, or city number 2 we can visit, or third city we can visit, or fourth city we can visit as the second city. So 3 possibilities are there that is shown in this diagram. After visiting 1, we can go and visit second city or third city or fourth city. And after visiting second city, we have 2 options. Either we can go to third city or fourth city. After visiting third city, we can visit fourth one. Then afterwards, we can go back to starting position itself. Here in this path, after visiting fourth city, we can go and visit third one. And then we can reach the starting city. And if you choose this particular path, after the first one, we have visited third city. After that, we can go to the second city or fourth city. If we choose this path, after the second one, we can visit fourth one and then the first city. Here, after the fourth city, second city can be visited and then first city can be visited. Similarly, in the third route, after visiting first city, fourth city is visited, and then 2 options are available for the third one. Either we can go and visit second city or third city. If we visit second city, the next one is going to be the third city. Then afterwards, the starting city will be visited. Here in this path, after the third one, we can go and visit second city. And then at last, we can go back to the starting city. According to dynamic programming technique, smaller subproblem will be solved and its results will be recorded. Using that, the next level of subproblem will be solved and so on. So it is solving problems by overlapping of subproblems. So initially, we are going to solve the smaller subproblem. That is, we are going to find the shortest path from one vertex to the starting city or from one city to the starting city without any intermediate vertices, without any remaining vertex. So first of all, we are calculating the shortest path between 2 and 1. From the second city to the starting city, then from the third city to the starting city, then from the fourth city to the starting city without any intermediate vertices. So we are calculating the shortest path with no remaining vertex. So we are finding G of 2, 5. This is what is the cost matrix which is available here, or weight matrix which is available. This matrix gives the distance between the various cities or the distance between the various vertices. Okay. So here G of 2, 5. From second city to the first city without any intermediate city, what is the distance? That is what we have to write here. So here in this table, we have to see that is C of 1, 2 comma 1. That is what we have to see, and that is 5. That value only we have written here. Then the next one is g of 3 comma 5. That means we have to find the value of 3 comma 1, and that value is 6. That is written here. Then similarly, g of 4 comma 5 is equal to 8. We are taking it from the table, and that is also recorded here. So we have solved the smaller problem without any intermediate vertices, and the corresponding results are recorded. With the help of these results, the next level of subproblem are going to be solved. Now, next level means we are going to solve, or we are going to find shortest path from one city to the starting city with one intermediate city. Okay, so with one remaining vertex, we are going to find the shortest path. If you choose this one, this path, this part of the problem from the second city to the first city, having third one as the intermediate city, what is the shortest path? That is what we are going to find in g of 2 comma 3. Then similarly, the next one which is available here is, we are at present, as of now, we are finding shortest path from 2 to 1 only. Here the intermediate vertex is what? It is 4. So that is going to be found here, g of 2 comma 4. So this 4, it represents intermediate vertex or city in between 2 and 1. So one remaining vertex, we are calculating all the shortest path with one remaining vertex or one intermediate vertex or one intermediate city. That is what we are calculating. Similarly, this path, that is g of 3 comma 4, we will be calculating. 3 comma 2 have to calculate. 4 comma 3 we have to calculate. 4 comma 2 also we have to calculate. So these are the values, or these are all the computations needed to be done. Now we are going to find the value of g of 2 comma 3. Here, what is I? Your I is equal to 2. K is taking value from this set. This set is containing only one element, so only one k value is possible here. If multiple number of k values are there, then we have to compute values for all the k values, and we have to choose the minimum. Here only one k value is possible, so only one computation we have to do here. So we are applying the formula here. So it is going to be minimum of Cik. What is I? I is 2, K is 3. So I am writing this one as C23 plus G of, this is what is the formula we are using. G of K comma, K is what? 3. 3 comma S minus K. Okay. So this is what is the set S. In this set, other than K, whatever the remaining vertices available in that set, that we have to write. Here only one vertex 3 is there, that we have taken. Other than 3, nothing is there. So I am putting 5 here. Okay. And then close parenthesis. What is C23? C23. See the table. C23 is what? It is 9. So it is equal to 9 plus g of 3 comma 5. We have calculated what is g of 3 comma 5. That is equal to 6. This is what is g of 3 comma 5. So 6 we are taking, which is equal to 15. 15 is the g of 2 comma 3. Okay. So in this way we can do calculations for other values also. So if you do the calculation like this, g of 2 comma 4 will be 18, g of 3 comma 2 will be 18, then 3 comma 4 is 20, 4 comma 2 is 13, and g of 4 comma 3 is equal to 15. Here when we are getting this 15 means when k is equal to 3 only we are getting this 15. We have to remember the k value which is minimizing the length of the path. Okay, so 3 is the k value which is minimizing the length, that we have to remember. Okay, then now we are going to solve the next level of problem, that is we are going to find the shortest path from one particular vertex to the starting vertex with the two intermediate vertices. So we are going to calculate g of 2, 3, 4, then 3, 2, 4 and 4, 2, 3. So this is what is the part we are going to consider. From 2 to 1, using 3 and 4 as the intermediate vertices, what is the shortest path? Similarly, from 3 to 1, using 2 and 4 as the intermediate vertices, what is the shortest path? Similarly, from 4 to 1, with the help of or in between 2 and 3 as intermediate vertices, what is the shortest path? That is what is the calculation we are going to do here. And here, let us do g of 2, 3, 4. What is your S? S is containing two vertices 3 and 4. K will be taking value from this set S only. Okay. So, g of 2, 3, 3, 4. Okay, which is equal to, is the value we are going to find. Here, our I is equal to 3. This is what is our I value. Okay. So, apply this formula. This is what is the formula we are applying. So, which is equal to minimum of 2 k values are possible. Now, we are taking 3 as k. Okay. So, C23 plus g of k, k is what? It is 3. 3, s minus k. 3, 4 minus 3. So, which will be equal to 4. Okay. So, this is what is the value we are getting. And if you take this one, C23, what is C23? C23 is equal to, this value is equal to 9. And G of 3, 4, G of 3, 4 we have calculated here, and that is equal to 20. 9 plus 20 will be getting 29. 29 is the value we are getting here. Okay. Then, now we are going to do the calculation with 4 as k. Okay. So, C24 plus G of 4, 3, which is equal to C24. What is 24? C24, this value 10 we are taking from the table. G of 4, 3. G of 4, 3, this value it is 15. So, that value we are taking. What is the minimum? 25 is the minimum. Okay. So, what is G of 2, 3, 4? Among these two values, we have to choose the minimum. Which is minimum? 25 is the minimum. So, your G of 2, 3, 4 is equal to 25. Length of the shortest path from vertex number 2, city number 2, the starting city 1 is what? It is 25. Okay. So, after visiting 2, what is the next city to be visited? Among this 3 and 4, 4 is the next city to be visited. Okay. So, in that way, we found this value. Similarly, we have to do the calculation for G of 3, 2, 4 also. Here we are getting 25 and G of 4, 2, 3, that is equal to 23. Okay. Now we are going to solve the next level of problem. What is that? From the starting city to itself, using the other 3 cities as the intermediate cities, what is the shortest path? Here only we are finding the length of the shortest tour, whatever is available, starting from city number 1. That we are going to find here. With the help of all the results, whatever we have calculated till now, we are going to find the solution here. Here, what is S? This is what is your S. S is containing 3 values, 2, 3 and 4. So, 3 k values are possible. Okay. What is I? I is equal to 1. Now, apply the formula. Okay. So, which will be equal to C12 plus, we are taking 2 as the k value here, C12 plus G of 2, 3, 4. Okay. So, which is equal to 10 plus 25. And the next one is C13 plus we are taking third vertex as the k value here. So g of 3 comma 2 comma 4. Okay, so which will be equal to 15 plus 25. Then the next one is next k value. Next k value is what? It is 4. So C14 plus g of 4 comma 2 comma 3. Okay, so which is equal to 20 plus 23. Which is minimum? 35 is minimum. Okay, so 35 is minimum. How we are getting this 35? When k is equal to 2 only, we are getting this minimum value 35. So which is equal to 35. What does it mean? After starting the tour from very first city, what is the next city to be visited? Which k value is giving minimum length here? 2. So we have to go and visit second city. Now we have to see the computation of g of 2 comma 3 comma 4. Where is g of 2 comma 3 comma 4? This is what is the calculation, g of 2 comma 3 comma 4. Here we are going to find the next city to be visited. After visiting second city, whether we have to visit third city or fourth city, that is what we are going to find here. See the calculation. Which calculation is giving minimum value? This is what is the minimum value, 25. When we are getting 25, when vertex number 4 is acting as k value only, we are getting this 25. So after the second city, the next city to be visited is city 4. Okay, so here we are visiting 4. Now we have to see the next calculation, that is g of 4 comma 3. So this part we have to calculate, that is we have to see, we have to check g of 4 comma 3. This is what is the calculation. Here only one k value is possible, and with that k value only we are getting this minimum value 15. What is that k value? Vertex number 3, that is city number 3. So after visiting fourth city, what is the next city to be visited? 3 is the next city to be visited. After 3, we have to go and visit first city. This is what is the shortest tour we found, and the length of this tour is 35. Okay. Thank you, students.